Good morning, everyone. Thank you very much for joining us for another Artex Academy webinar. Today we'll be speaking with Dr. Mike Brouk from Kansas State University. He'll be talking about the benefits of dry cow cooling. Just a couple of quick things before we get started. At any point in time, you can ask any questions through the question and answer section on the bottom of your screen or through the chat feature. We'll be taking those and answering them at the end of the session, and we'll be doing a short poll at the end so that you can let us know how we did. So Dr. Brouk, I will turn it over to you.
All right, appreciate everyone joining today, and I'll get a screen up on share here in just a second for you, and we'll get started. All right, should all right, we okay on the screen there, Karen?
Yes, sir.
All right, we'll go ahead and page down through this then. So today I want to spend a little bit of time just talking about cooling dry cows and some things that we can consider as we do that to try to improve the efficiencies on our dairy farms. So just a little bit maybe about my background. Grew up in the central part of the United States on a crop production farm, and got interested in the dairy industry as I moved into my early college years. Since graduating with my PhD from South Dakota State University, spent about 30 years now in the feed industry, and also most of that time actually with universities. So been 3 different universities, currently at Kansas State University. I've been here starting on 23 years. So I'm an extension dairy specialist here as well as professor, and handle things in the areas of nutrition, facilities, cow cooling that we'll talk about today, and then also have been doing a lot the last 6-7 years with robotic milking. So as we look at heat stress and how it impacts dry cows, just wanted to let you know that some of this stuff is not real new. Back in the 1980s, there were several studies conducted that showed that we could actually see a decrease in birth weight of calves when we had heat-stressed dry cows after they calved. And some of those studies were conducted in the 90s as well as 2000s as well. So that continues to be something that we know happens. There was also a group of folks that in the 80s that looked at milk production and the next lactation, cooled cows during the dry period versus cows not cooled, and there was a significant advantage if we cooled cows during the dry period. The decrease in fertility, again, first studies showed that in the 1980s, and this would be for cooling cows during the dry period. So there is some impacts as we go into the lactation. The decrease in immune function, that was in the 2010s. Some of the researchers across the United States looked at that. So again, cooled cows, dry cows had an increase in their immune function. Reduced calf growth rates. It's kind of interesting. We knew that there was a decrease in calf birth weight, but then folks started looking to see, so how well do those calves actually grow if the dam was heat stressed during the dry period? And we found that their heat stress during the dry period does have impacts on the growth rate of calf, even though we're past calving when that happens. And then finally, just a decrease in dry matter intake during that dry period. As we go into the transition period, heat stress can drop our dry matter intakes about 3.3 pounds per day, according to one of the studies. And for those of you that work maybe in the nutrition area, we actually look at dry matter intakes in pretty fresh pens. I think you will recognize that we very often do see a decrease in dry matter intake during the summer months when we're experience heat stress, and it's even worse if we do not do something to cool those particular animals. So very important that we do that. Thought I would maybe just summarize. When you look at the body of data out there, there's actually a lot of data that has been collected over a period of years that indicates that we end up with less milk production in the next lactation when we do not cool dry cows. And some of these studies looked at cooling dry cows for 60 days. Some of these looked at a shorter period. I think the shortest one is about 21 days, so basically the in the pre-fresh pen. But as you look at kind of the average of this, average loss across most of the studies would indicate about 11 pounds per cow per day in the next lactation. So as you think about that and think about 340 days of lactation, it'd be about 3,700 pounds of milk for each cow that goes through this heat stress situation as a dry cow. So if milk is 17 cents a pound, that's a little over $600 of lactation. And probably somewhere between 20 and 40% of the cows are dry during heat stress across the United States. So depending on what your calving intervals are and those sorts of things, may have a higher percentage. Maybe your heat stress season is longer, so you have a greater number of cows in your herd that are impacted by this, and we'll talk about that a little bit more in a minute. One of the things I guess I wanted to do is just real quickly, the way cows lose heat, whether they're a dry cow or a lactating cow, really doesn't change. So we've got really 4 different ways that they exchange heat with the environment. The radiation, when we think about solar radiation, that's important because that's actually heat input. As far as how she actually gets rid of heat, though, when she's under heat stress, one of the important studies I think we take a look at is how does an animal actually lose heat? And we draw a line here at about 70 degrees, okay? And you look at those percentages to the right of that line, you can see that a high percentage of the heat that she actually exchanges with the environment is associated with evaporation or evaporative cooling of the outer body surface. Now, this study would have been done without any additional water applied to her body. This would be based just simply off the amount of heat she was exchanging due to the evaporation of sweat. You can also see that the respiratory tract, the light blue area there, by the time we get closer to 90 degrees, about 25% of the heat that she's exchanging is actually through evaporation of water and in her lungs, and very important way that she loses there. And then as you look at the non-evaporative, like conduction radiation or convection, that's the yellow portion of this graph. Again, as we approach 80, 90 degrees, those 3 methods of exchange really don't account for very much of the heat that she actually exchanges with the environment. So the evaporative cooling, whether it be of the outer body surface or the respiratory tract, are really the 2 main ways that she's exchanging heat with the environment. And much of what we've done here at K-State is actually look at ways that we can increase the amount of heat she loses in those ways, okay? So when we think of the temperature humidity index, again, we often talk about this when we talk about lactating cows, but you know, it does hold true for the dry cows as well. And actually, several researchers have indicated that the critical temperature, or THI, rather, index for a dry cow is 68, just the same as it is for a lactating cow. So those relationships really don't change. So if we think about heat production from a lactating cow, we know it's very high. Dry cows obviously have much lower heat production. They're consuming less feed, but have a higher critical temperature. But again, we still use a guideline of a TH of 68 and above is when they're in heat stress. So when we think about heat exchange, if we don't have enough heat exchange, whether it be a lactating cow or a dry cow, we end up with storing heat in the body. And when we do that, we're going to increase body temperature over time. And that's really what we don't want to do. And as you think about evaporating water off the cow's body, basically you get about 1,000 BTUs required for every pound of water that's evaporated. So adding a little bit of water to the body is an excellent way to take heat out of that body. So I want to just cover a couple of things here. And airspeeds. What kind of airspeed do we need to get effective cooling? So this is really what we looked at in this particular study. And you can see the red line is controls. So there was no soaking involved in this, nor was there any supplemental fans. So if you're not doing anything for the cow, we're not going to get effective cow cooling. As you increase the speed of the air, you increase heat loss and you create more cooling. So as airspeed went up from 2.25 miles per hour, which is the pink line, to 4.5 miles per hour, the blue line, or 6.75 miles per hour, the green line, you can see that we had an increase in heat loss from the animal, and we actually lowered her body temperature. So we know airspeed is very, very important. And again, this was in combination with soaking, but same soaking cycles for all three different levels of air movement. So having adequate air movement over the cows is very, very critical in trying to cool them. So again, this technique would apply for dry cows as well. And having that airspeed over those animals at 6 to 7 miles an hour is really probably where you want to be if you're going to be effectively cooling them during periods of heat stress. So again, a lot of our work at K-State is really looked at how we incorporate soaking systems at the feed line along with fans. And we've done most of our work here with lactating cows, although others across the United States and actually around the world have taken these same techniques and applied it to dry cow cooling. So that chart that I showed you at the first that showed all those different studies that looked at dry cow cooling, those studies were using systems like this rather than for lactating cows, it was for dry cows. So it is possible to do this. So really the heart of the system, I think, is the controller that gives us an opportunity to change the amount of water that we're putting on based on temperature. As temperature rises, we can put on more water, and when it's cooler, we can put on less, or we can put on none at all if we're not in a heat stress situation. And these controllers are very, very durable and programmable, so you can program them, and basically they function just fine. We've got examples of these that have been on farms for more than 15 years and still operate today without any problems. The power goes off, the system actually holds the programming, and it just starts wherever it left off when the power failed when it comes back on. So really easy to do. The other critical thing is that we have a check valve in each of those nozzles. We don't want those lines draining out in between the soaking cycles, and want to be able to have water right there when the system turns on. So these check valves are very important. These are examples of numbers and stuff that you would find if you were looking at T-jet type equipment, but you could go to your local spraying systems company, and there are other manufacturers that manufacture very similar equipment to what's shown here. But the check valve is very, very important to the whole system to make sure that things do not drain out. So often do you need to soak the animals, and that's really what I want to talk about here for just a minute. Is that we've got some issues here that if we just blow hot air on hot cows, we really don't do much for them. So that's the two red lines here. So The solid red line is the control where there was no fan, no soaking, and the hashed line is where we just blew hot air on cows. So we got the body temperature of the animals, and you can see that, you know, when you blow hot air on hot cows, it just doesn't work. We really don't get very much cooling when we do that. We're a little bit better. I mean, we do lower body temperature compared to not doing anything at all, but really the animal is still in heat stress if you look at a body temperature that exceeds 103.5. So, and this was on a day when the actual temperature in that facility was about 95 degrees. So, I mean, it was a warm day, and warm air, just there's not much of a temperature difference between your body surface and the air. And as a result, we're just not going to get much cooling. Interestingly, the orange line there, the solid line, is just giving her one soaking cycle every 15 minutes. So just enough water on her back that it starts to run off. If you soak her just once every 15 minutes, you actually drop her body temperature more than if you put a fan on it without any soaking. And then the dotted orange line is if you add the fan with that. So again, this would be about 7 mile-an-hour airflow over her in addition to the water. And you can see that we really significantly can drop the body temperature of these cows by just having a fan and soaking them once every 15 minutes. The green line, solid one, is soaking them once every 10 minutes. And then the hashed green line is soaking them every 10 minutes in addition to applying a fan as well during that time. And then the solid blue line is soaking them once every 5 minutes, and the blue hash line is soaking them every 5 minutes, again with the fan employed. So you can see that as we increase the soaking frequency and as we increase airflow over the cows, we increase their heat loss. And we can actually, you know, take an animal with the 5-minute soaking cycle that's really hot and running a body temperature of 103.5, and we can take her down really close to 101.5 in just about an hour and a half. So these measurements were taken over 5-minute periods of time as we soaked them. The first, I might explain, the first 3 cycles, 1 through 3, that was without any of the treatments turned on, and then we turned the treatments on and started measuring. So you can see that initial 15 minutes there at the first, or on the left side of the screen, body temperatures were going up while we waited to turn on the systems. So again, soaking frequency is important when it's hot, as well as having airflow. So one of the things that we really struggle with is just water utilization, okay? And in reality, in a lot of our systems, only about 25% of the water we put out with these systems is actually going to hit the cow. And a lot of that's associated with when she's at the feed line. So when you start thinking about cooling dry cows, and if you're going to use this type of a system to cool them, how are you going to get them to the feed line so that they can actually get up there and do that? So if you look at the amount of time that they're spending, this is for lactating cows, so it would be probably more time spent laying if we were talking about dry cows, but they really don't spend a lot of time at the feed bump. And they're going to, for dry cows, you're going to probably be looking at maybe more like 15% of the total day. So how are you going to get them up there, and how are you going to get that working? So as you think about when they're going to be there, they're going to be there when you feed, maybe when you push up feed. So some ways that we could do this, and I think we ought to really think about this in this area, is that a sensing system to detect when cows are actually there. And that is doable. We've looked at doing this with lactating cow pens, but it gets kind of expensive because of the number of sensors we would need. But in our dry cow pre-fresh area, we could probably do this more economically, and maybe that'd be a way to do that. Cows aren't there, the system doesn't run. If they are there, it detects them there, and then we can run the system. So, you know, our goal here is how could we reduce water demand? And there is maybe a simple way we can do that, and that's with a simple timer, so that the system's only on when we push feed up. Say it comes on and it stays, we push feed up or we deliver fresh feed, and it's on for, say, an hour after that activity. So that's one way to do it. If you know you're going to have the animals locked up for a certain period of time for vet check or whatever, that'd be another time when possibly you might want to use it to make sure we get cows soaked certain times of the day. So you can set these to have different cycles, different times of the day. It might be a way to reduce that water usage, and something that maybe you need to think about. The other thing, you can use this to draw the cows back to the feed lines. So let's say that you fed the close-up pen at 10 o'clock in the morning. The system ran for an hour, it shut off, and then maybe about 3 o'clock in the afternoon or 4 o'clock in the afternoon, you'd have the soaking system come on for another hour or so. And that might actually draw cows back to the feed bunk because they'd be seeking the coolness of the water that's being put out. So really you want to wet the cow down, and again, enough water to get it to start coming off of her back. And then you need to dry it. So you need the fans to do that. And it's important that you use these in combination. As soon as that water is dry, let's put on down another soaking cycle. As temperature rises, we increase the frequency of the soaking cycle. So the length of the soaking cycle is really dependent on the nozzles and the water pressure that you have in the line. Actually, what we're trying to do is put down about 0.03 gallon per square foot, and we usually calculate that based on about a 2x4 foot grid. So basically, the space of one headlock. And generally, these type nozzles are mounted about every 6 to 8 feet on that line. So you're covering 3 to 4 headlocks with a single nozzle. And there is overlap between the nozzles, obviously, but that would be the suggested installation and our design for water usage per cycle. Okay, so I want to talk a little bit about fans as it relates to dry cows, because I think this is really important. One of the things that has happened in our industry in the last 10 years is we have drastically changed the design of fans. And when I started working in this area about 20 years ago, about all we had were basket fans. That's really about all that there was. And those had some issues. They didn't really get the air to where we really wanted it, where we really needed it. And over time, the industry has made some really, really significant changes. And one of the changes has just been these larger fans with the louvers. So we actually put air down onto the cows, and really can move air further, so fans don't need to be as close together, and it actually does a more effective job of getting the air down on the cows in the freeze-thaw beds, and really a great improvement. Another improvement that you might want to think about, and this would apply for your lactating barns as well, if you're dealing with a barn that's got a fan system that you put in, say, 7-10 years ago, it's the basket fan type system, I would really encourage you to take a look at, is it time to refan your building? And in doing that, take a look at some of the new options that are out there. One of the advantages of a fan like this is you can buy this with an option that has a VFD on it. And so we can actually operate rather than just on or off. When it's cooler, we can run a little bit of airflow. We could run that fan, say, at 20%. As it starts to warm up, we can maybe jump up to 40%. And then when it gets really hot, let's say it's 75 or 80 degrees, we're running at 100%. And that really saves on energy during the cooler parts of the day or cooler parts of the year. And it also does an effective job of cooling the cows. So really some neat things to take a look at. Also, if you're thinking about refanning a building, you might want to check and see with your local electric co-op or electric supplier, see if there's any incentives, because these are more energy efficient than the current basket fans you probably have installed. So there's ways of using a combination of the louvered type fans as well as the panel style fans. So you might use louvered style fans over freestalls, and then over the feed line, you might switch to a panel type fan. In some barns with a little bit of an angle on the louvered type fans, they actually can force air over on the feed line from the fan over the beds. And we do have some installations where they actually eliminated the fans on the feed line. So another way to change what we do. As you think about the airflow pattern that we get from basket fans, it might look something like this. So the blue areas would represent that airflow pattern. When you go to these large louvered fans, or you go to some of the newer style panel fans, it starts to look more like this. So we spread that air out over a greater area, and we also do a better job of actually getting it down on the freestall beds for the cows. So I think that's a really important design change that we have that can really help us. So again, we mount these further apart than the typical basket fans. For basket fans, we generally considered we wanted to mount those so that we get effective airflow. So for a basket fan, we generally figured that a 3-foot fan would push air about 30 feet, or a 4-foot fan would push it about every 40 feet. And that would be our mounting distances for the fans. So these newer fans are wider, they're larger, they're more effective in moving air, and a lot of times we're mounting those 50, 60 feet apart and still getting effective cooling for the cows. So as we think again about how cows are losing heat, again, we just need to remember that blowing hot air over hot cows is not going to be a solution. The same will be true for our animals that are in the dry pen or in the pre-fresh pen. We need to add some water. And getting that water down on the cow's back is, at the feed line, is an effective way to increase the cooling that she experiences. Now, some cases it's kind of hard to do this, so fogging systems are being utilized in some cases. And I can tell you that the idea on this is that we're going to evaporate this fine mist of water, and that's going to cool the air. And it does work. And we've used it for decades in very arid parts of the country. You think about Arizona, you think about places like Saudi Arabia. This type of cooling system can work really, really well. But we've got a lot of capacity to evaporate that water. So as relative humidity goes up, and I know some of you listening are probably in areas where you have higher relative humidities, but when you get to a relative humidity of 80%, evaporative cooling just isn't going to work very well for you, okay? Because you just don't have the gradient there to evaporate the water. As you drop down closer to 50% relative humidity, then you have the ability to evaporate some water and actually cool that air that's coming in. Now, one of the things I'd have you think about as you look at this chart is that you may be in an area where at night, after the sun goes down, relative humidity goes up, and maybe relative humidity goes between 90 and 100% overnight, very typically. And then in the morning, as it starts to warm up, relative humidity starts dropping back. And by noontime, or maybe 1 o'clock in the afternoon, you're back to 50% relative humidity, or less in some cases. And if that is the case, then you do have the ability to take advantage of evaporative cooling. But again, it's going to be limited by that relative humidity. Where evaporative cooling really shines, and where we can really get the greatest changes in THIs, when we're operating in low relative humidity situations. So, 20, 30%, we can get huge swings in air temperature by using evaporative cooling. So it works really well there, and a way that we can cool the cows. I want to just cover something that we did on a pack barn, and we used these louver type fans, and in front of those fans is also a high pressure mist system. So this was a study we actually conducted here in Kansas, and this particular farm switched animals back and forth based on milking schedules. So this was done with lactating cows, but I think this would apply for dry cows as a way to cool them. So as you can look, the yellow there, the bedded pack barn. So just blowing the fan on the cows versus fan in fog. So switchback study, so you can look at the hours spent above 102.2. As we increased and used evaporative cooling along with the fan, we had fewer hours where the cow's body temperature, core body temperature, was above 102.2, and more hours that she was less than 101.5, and more hours that she was less than 101.5, or between 101.5 but under 102. So very, very significant change. I also looked at animals that were moving in and out of the tie stall barn. Again, same situation there, that the animals that were cooled with the evaporative cool system spent fewer hours where they were actually under heat stress, as opposed to just the fan as well. So evaporative cooling works, and we've known that cellulose pads are a way to do that fairly efficiently. So this is something that we did at K-State to cool our prefresh cows. We had a organic bedding there that you can see on the left side of the screen, and a sidewall of the building that we took advantage of. And we basically built a small lean-to onto that so that we could put fans in the building wall that would blow in, and they would draw air through an evaporative pad that was on that lean-to. So need a little bit of an air chamber to mix the air, but it gave us a way to actually cool the cows. So this is the actual barn. So you can see up there in the upper left is the fans installed there, and then down there on the lower portion, we're putting on the essentially the lean-to, and then the completed would be over there on the right. So that's kind of what it looked like. So we got the evaporative pad, and we can actually now blow cool air on our cows. So how did it actually work? Some data. So the red line is the ambient temperature, and the blue line is the evaporative pad. So we were basically taking the air temperature, which was running about 93 degrees, down to about 80 degrees. So a nice drop there in the afternoon hours. So you can see the time of day across the bottom of that screen. And we actually ran the unit 24/7 while we were collecting this data. So we were trying to do some nighttime cooling. It was time of the year when we had lower relative humidities at night, so we were actually able to do that. As you look again at THI, because we are adding water to the air, we're adding to relative humidity, so are we lowering THI? And again, the ambient would be ambient THI, and that was running in the afternoon hours about 82, and with the evaporative pad, we were under 78. So very significant drop in THI, even though we're adding some additional humidity to that air. So how did the cows perform? That's really important. So again, in the switchback study, we looked at the vaginal temperatures over time. Red line is the pads off, and the blue line is the pads on. So again, we got most of the cooling in the afternoon hours, and we can see that those animals that where we're not running the pads, we were still running the fans, but not running the pads, so there was no evaporative cooling involved. Body temperatures were 102.5, and a little bit higher. when we actually turn the pads on in the afternoon, we could maintain those body temperatures at closer to 102. And we did, in this particular study, we did shut the pads off about dark. So that's the reason why everything goes up a little bit as we get toward the later part of the evening. So very effective in cooling the animals. So as I think about, cooling dry cows, transition cows, and some of the issues that we might have with feed line soakers and the water that it accumulates, do we think about using some evaporative cooling in this area? It's a smaller area. Is it the most effective? Maybe not. Is it better than doing nothing, I guess? And again, if you have the temperature gradient and you also have low enough relative humidity in the afternoon, and that's the only way that you can effectively cool dry cows, keep in mind, hot air over hot cows is not going to cool them. So if this is our only option in those particular areas, I think it is something that we can do. And we've shown that it'd be effective in cooling those animals. So again, when you think about cooling dry cows, there's lots of different studies out there that show an increase in milk production the next lactation when we cool the dry cows. And again, some of these studies were over longer periods of time than others. One of the classic studies looked at the whole lactation. So the line with the solid squares, those were the animals cooled during the dry period. The open circled line, those are the animals that were not cooled during the dry period. All animals were cooled during lactation. But again, the top line there, you can see that through 40 weeks of lactation, those animals that were cooled in the dry period had a higher level of milk production than those animals that were not. Okay, so this is real, and it occurs not just for a short portion of lactation, but the whole lactation. I mean, you think about peak milk production. If we can cool cows during the dry period and we can increase peak milk production as a result, is what this graph is really showing us, then that means that those animals maintain a higher level of milk production throughout the lactation. And we normally say that for every pound of increased peak production we get anywhere from 250 to 300 pounds on the lactation. So when we start talking about the differences here in some of the studies, if you average those things out, it's about 11 pounds per cow per day increase in milk production. So that's 11 pounds on the peak times that 3. That's a lot of milk that we need to think about. So the University of Florida put out a nice summary of what we could invest in dry cow cooling. And they looked at different states based on the number of days of heat stress that cows might experience in those areas, as well as if they put up a new barn with fans and sprinklers versus just fans and sprinklers in an existing barn. So those increases in production represent what it would cost to, or what the amount of milk would be required if we were going to get a 3-year payback based on 11 pounds per cow increase in milk production. And I think they used 18 cents for the price of milk in doing the calculations. So, if we're just adding fans and sprinklers, it doesn't take a lot of milk. We're building a whole barn, it's going to take some more milk. If you're in Wisconsin, it's going to take more milk than it would be, say, if you're in Florida, Texas, where you have more heat stress. So the higher the degree of heat stress that your dry cows are subjected to, the more reason you have to do something about it. So on average, across the United States, about 96% of the dry cows experience heat stress. Across the United States, the average dry cow experiences 96 days of heat stress each year. On average, all cows across the United States lose about 640 pounds of milk per lactation. It's about $810 million a year that we lose in our industry. And And dry cow cooling is profitable probably for about 89% of the cows in the United States. We're talking about just the fans and sprinkler systems. So it is something that we can do. Some suggestions that I might have for producers is just take a look back in your records, how many calves or how many animals are dry during the summer. And then start looking at what is the cost to upgrade your dry cow and pre-fresh facilities. Let's say you have 1,200 calvings a year, it'd be about 100 a month. So basically you got space for about 200 dry cows out there, maybe a few more. And then what would it cost to put in fans and soakers, or maybe what would it cost to put in fans and soakers and build a new building? So if we had 100 cows and we lost 3,500 pounds per lactation for those animals that are dry during the summer, milk's worth about 17 cents a pound. That's about $63,000 a year that we have the potential to gain back by installing a cooling system here. If you're calving 400 or taking 400 through the dry period during the summer, you got about $250,000. So my point is there's a lot of money on the table here, and we do have an opportunity to take advantage of that. And these systems generally do have a very quick payback for them. So as you think about cooling your dry cows, there's lots of implications on the animals as they come through that dry period, things like intake and maybe some issues with metabolic issues when they come fresh. But we also are impacting the milk production, the next lactation, as well as the calf, not only on body size, but in weight, but also on their growth rate, as some of the studies have shown us. So, the key issues here is, are we in a situation where we have heat accumulation in these dry cows? If we do, we need to increase the amount of heat exchange that they have during the day. I'd encourage you need to work with what you have and think about the economics over a period of a few years. Most of these systems will pay for themselves in about 3 to 5 years easily, and sometimes quicker if you're in an area that has higher levels of heat stress and greater opportunity to take advantage of what you install. So again, I want to thank you for that, for some of the collaborators, some of the data that you've seen earlier in the slideshow. And then thanks just to Artex for the opportunity to talk about cooling your dry cows, and hopefully you've found something here that you might be able to incorporate it either on your farm or a farm that you work with. And with that, I guess we take some time for some questions.
Thank you very much. The floor is open for questions. You can ask them through the question and answer section or through the chat feature. And we'll just give it a few minutes so that people have time to ask their questions. Well, I think you must have covered all the bases.
Oh,
here we go. What is the impact on cooked calves?
The impact on
cooked calves. The calves themselves.
Oh, okay, sure. So a couple of things. The decrease in body weight at birth has been shown to be significantly less when we do not cool the dry cows. And that's been shown in about a half a dozen different studies. The other thing that a couple of studies have looked at is they've looked at the calf growth rate after birth. And they found that those calves that came from animals that were not cooled during the dry period actually had a slower growth rate than those animals that came from animals that had been cooled during the dry period. So there seems to be some metabolic things that are going on in the calf if they're subjected to, or if the dam is subjected to heat stress during the dry period. So.
Perfect. Thank you very much. What happens to those calves as lactating calves or lactating cows?
Well, I do not know that anybody's actually specifically followed them through the next lactation, although it seems like there was an article that came out that did look at maybe a little further down the road, and but I don't know if they actually addressed that. I mean, based on the fact that the calf is growing slower, and based on some of the things that we know about slower growing calves versus faster growing calves in terms of their ability to milk in the first lactation, calves that grow faster, particularly earlier in life, do have an advantage that way when we look at accelerated growth programs. So would assume that the same would be true for heat stress, calves coming from heat stress dams versus dams that were not heat stressed.
One of the questions is, what about tube ventilation in dry cow barns?
Well, again, are we talking about issues with air quality? Or are we talking about trying to cool the cows? Earlier in the seminar, I think I demonstrated that when we talk about cooling cows, we need to have adequate airflow, airspeed on the animal. And, that's 6 to 7 miles an hour. A lot of times with air tubes, we're not going to get that. We're going to be maybe a mile, mile and a half. Now, if we're in a situation where we don't really need a lot of cooling, in other words, we're not, it's not 95 degrees outside, and we're not really suffering from a lot of heat stress. Maybe we're in the low 80s. Is that enough to provide some cooling? Probably so. So depending on your environment, it might, if you don't have a very stressful situation, it might be able to help those dry cows. But again, if you're warmer, the real way that we cool the cows is either to put water on her back and evaporate that water from it, or we somehow use evaporative cooling to cool the air, so we're blowing a cooler source of air onto her.
Thank you. Did you find any lameness issues with heat stress dry cows?
I didn't catch the first part of that.
Did you find any lameness issues with heat stress?
Yeah. So one of the issues that we have with animals that are hot is they will stand. So she'll spend more time on her feet. As she spends more hours on her feet, that does generally increase the situation with issues of lameness. The other thing that tends to happen is when they're standing, they also tend to, during the hot weather, sort their feed more. So we get less fiber intake. So as a result of that, there's sometimes a combination thing that can occur, that we have heat stress that's causing her to change her feeding behavior, which makes her more prone to acidosis.
Thank you. So that looks like the end of our questions. I'd like to thank you for joining us. And if you're interested in more Artex Academy webinars, you can go to artexbarn.com, upcoming events. So thank you again, Dr. Brouk.